Sixth grade lesson 10.7 is finding the area of composite figures. And so we've learned the formula for area of parallelograms that we could use for rectangles and squares as well, because those are also forms of parallelograms. We've learned the formula for area of a triangle. Area equals 1/2 the base times the height. We also learned the formula for area of a trapezoid. Area equals 1/2 times base 1 plus base 2, all times the height. So we have those we've been working on, but what if the figure we're looking at isn't really one of those? For example, what if our shape looked like this? I don't have a formula for that, right? I have the formula for parallelogram. I have the formula to find area of a triangle. I have the formula to find area of a trapezoid. I do not have a formula for this. And so this is sort of what they mean by composite figures. They're figures that don't quite fall into the easy range of this. When you come across those, you're going to look at those and see, how can I change that shape, or how can I cut that shape up into pieces so that I can use one of these formulas or two of these formulas or three of these formulas. So step one when you come across these is to take a look and identify how you can break that composite figure into shapes that you have formulas for. And this one has a couple of possible options. I could take this rectangle. There's a twin to it. It's got a length of 4 and a height of 10. So I have these two rectangles. I can take these two triangles and then this square. It looks like it's a square because it's 4 by 4. So I could take this square. And so I can calculate two of those, base times height, two of these triangles, 1/2 base times height, and one square. And I can then, when I get all the areas for all of those, I can add them all together. You could have also said, you know what, I see I've got this rectangle and this rectangle, and then I'm just going to include this whole thing and call it a trapezoid and use the whole thing. So you could do it that way too. My advice on this is make sure you have lots of room on your paper. You keep things nice and neat so that you can see what's being calculated. So step one would be identify how you're going to split it up. I think your book breaks this into 2 rectangles, 2 triangles, and a square. I'm going to go ahead and break this up into 2 rectangles and the trapezoid. Less calculations to do. I've got the formula, why not? Okay. All right, so I'm going to go ahead and break it that way. So I'm going to identify what my shapes are. And now that I have identified them, I'm doing rectangle plus trapezoid. Now I'm going to, I always do this every time. I say I identify which shapes I'm dealing with. I'm adding them together. The next step I'm going to do is identify which formulas I'm using. Rectangle is going to be a parallelogram. So I'm going to write the formulas underneath each of these. Okay, and I've done that. So now the formulas are there. The next step is to fill in the dimensions for each of those separate shapes. So for the rectangle here that I'm looking at, I have a base of 4 and a height of 10, or base and width, base and height 4 by 10. It's the same over here, 4 by 10, because this length is the same as this one here, and they told us that this 4 is the same as that. So I have 2 of those. I'm going to fill that in. The trapezoid looks a little trickier. It's not really, but it looks a little trickier because they didn't tell me the whole base. I have to be a little bit of a detective for the base 1 and base 2. Well, the base 2 is pretty easy. It's the same. If this is a square here, this 4 is the same as this 4. So I'll put that there, 4 feet there. This part is the same as this part. So I'll put the 4 there, same over here. So I can simply add that 4 plus 4 plus 4 for that base. So there was a little bit of extra work to do. It wasn't difficult work, but I had to do it. So my dimensions now are area equals 1/2 times base 1, which is the 4 plus 4 plus 4, 12, plus base 2, which is the 4 at the top, times the height, they gave that to me here, is 4. Now I go ahead and calculate. For this rectangle, 4 times 10 is 40. It will be added to this rectangle of 40. And I have a little bit of math to do here. Order of operations says parentheses need to go first, so I have to do that addition first. I will get 16 So now my new calculation is this. Half of 16 is 8, and 8 times 4 is 32. So I just add all of these together, because what I have found is the area, let me put this in a different color here, let's go with red. The area of this rectangle we found was 40. The area of this rectangle we found was 40, and the area of the trapezoid was 32. So to find the area of the whole composite figure, now that I have those pieces done, just simply means add them all together. 40 plus 32 is 112 feet squared, right? Because all of those required a dimension by a dimension, a unit by a unit. So feet to the second power. And that's it. We'll look at another example. All right, here's another example of a composite figure. It is like a boot-shaped thing. Weird boot, but a boot-shaped thing. And they did, for the measurements purposes, they dotted all the measurements for us. So it kind of gives us an idea on how we can split this up. I would split this up into this square, 12 by 12 square. Then I would do this trapezoid, and then I would do this triangle. So my shapes are triangle, square, trapezoid. So I'm going to write that down on my paper. And I'll write the formulas that go along with those. The triangles formula, area equals 1/2 base times height. I know that so quickly because I had it written up here. By the way, it might not be a bad idea to write that at the top of each of your pages just to make it easy for you if they're not already stuck in your brain. The square, I don't have one for a square, but remember squares are just a version of a parallelogram. They have two opposing parallel sides. So I'm just going to use the formula for a parallelogram. Area equals base times height. On a square, sometimes you'll see area equals side times side, or area equals side to the second power, because side times side is side times itself twice. So don't get thrown off by that. It's still a base and a height. It's just that they're the same numbers because the sides are the same size. Trapezoid, area equals 1/2 times base 1 plus base 2 times the height, as we learned in one of the previous lessons. There's my formulas. I always like to write them first. Helps my brain get organized. Now I will dig in to find the important dimensions and plug those in. For the triangle, area equals 1/2 times the base, which would be this 16 here, and then times the height, which is this part, 12. They gave me a dimension of this measurement here, but it turns out that's not a necessary piece of information. They're going to do that to you sometimes. So this is a base of 16 and the height of 12. So 16 times 12. Let's fill in the dimensions on that square. Base times height, or side times side, since they're the same value, the same measurement. 12 times 12. And on my trapezoid, I might have a little bit of work to do. We'll see. It's area equals 1/2 base 1, which is this amount right here. Well, since this part's a square, this amount will be the same as that amount. So that's 12 plus base 2, which is this 9 here, times the height. Well, they gave that to us right here, times 6. So not much detective work to do there then. Let's calculate those out. 1/2 times 16, or 1/2 of 16, is 8. And 8 times 12 is 96. That is centimeters squared. I will add that to the area of the square. 12 times 12 is 144. This one takes a little more work to it. 1/2 times, parentheses have to be done first, so 12 plus 9 is 21. And then remember, it's all multiplication in here, and use that to your advantage. If it's all multiplication, no other operations going on. I'm not tied now to order of operations. Multiplication is commutative. You can go in whatever order you want. Since that's an odd number and that's an even number, it's easy to cut even numbers in half. So I'm going to take advantage of that and say 1/2 of 6 instead of 1/2 of 21. So 1/2 of 6 is 3. And then 21 times 3 is 63 centimeters squared. So I have found the area of the triangle, the area of the square, and the area of the trapezoid. And now I just need to add all three of those together. That's 13, that's 20, and that's 3. So 303 centimeters square is the area of the whole odd-shaped composite figure. Okay, one more example, and I'm going to throw two little twists at you on this. This time they want us to find the area of the shaded space here, of this, the shaded part of this rectangle. So I have this whole area here, but I don't want this part. So in the previous ones, we were finding all the possible shapes, finding the area of those and adding them together. But if I want a hole cut out of it, your brain is probably already making sense of that, where you're saying, oh, well, I'll just find the whole area of the whole thing and then find the area of that and take it away, subtract it out. So yeah, that's how you would do that. The other little twist to watch out for here is, notice this is in inches, this is in inches, this dimension is in inches, this dimension is in feet. I cannot calculate those areas with different dimensions going on. So I have to make the adjustments right up front to make sure everything is in the same measurements, the same units of measure. Well, these are inches. This one is foot. It's 1 foot. And hopefully you remember by now how many inches are in a foot. And we'll just change that right off the bat so that it's not an issue anymore. There are 12 inches in a foot. So we're going to use that 12 so that we're using the same units of measure all the way across. Okay, I have a rectangle, which is a version of a parallelogram, two opposing parallel sides. So I'm going to use the rectangle. The formula for that, area equals base times height, or length times width, right? And then I have a square that I'm cutting out. So I'm going to put the little minus sign there. Area of the square is, again, squares are versions of a parallelogram, length times width or base times height. I just like to use the same one to keep it simple. I'm going to fill in the dimensions. I know I have a length of, be careful, that's not 1 foot. We canceled that out. We're going to use 12 inches times the height, which is 6. That'll give us the area of the whole thing, including that. But then I will subtract the little square, which is 3 by 3. 12 times 6 is 72, minus 3 times 3, which is 9, and 72 minus 9 is 63 inches to the second power. We're talking about area. It's always going to be to the second power. Your unit of measure will always be to the second power. Flat surface, 2 dimension. So 2 dimension represented by your to the second power. And so that's what you would watch out for. So as you go through your practice, are you adding a bunch of shapes together? Then you'd add them. Or are you taking a shape and cutting a piece out of it? Then you would do a bit of subtraction. Maybe you end up having to do a little bit of both. Depends on what they're looking for. The other thing to watch out for is make sure all your dimensions are the same before you start calculating. If one of them was given to you in feet and one was given in inches, you need to make an adjustment so that one is the other, so that they're all the same. And usually they're going to give you the ones that you tend to know the relationship between them. In this case, most of you know that 1 foot is 12 inches long. So make that adjustment so that you can calculate those dimensions. I think you're ready. It's just going to take some practice. Go get it.